Welcome back to GateX AIML. Okay. Today we'll see joint probability distribution. Before going to this, let us recap what we have done in the last video. We learned about discrete probability distribution, that is probability mass function, and then we learned about continuous distribution function, that is probability density function. Whatever learned there is just for single variable, okay, only one variable. We found out the distribution, but in the real world applications not sufficient. For example, if you take the machine learning algorithms to predict something, you'll be having a lot of features in it. They're all sometimes dependent, in not dependent, and also there's a multivariate, that means multivariable distributions. So if there are two random variables, then the distribution that we get from these two random variables or more random variables, two or more random variables, is called joint probability distribution. Okay. So here basically we'll be learning only for two random variables, both discrete case as well as continuous case. So this can be extended to any number of random variables. So for your syllabus it is only two variables, joint probability distribution. Let us try to understand. The first one is joint PMF, that is for discrete random variables. We call it as probability mass function. So if we have two discrete random variables, then we call it as joint probability mass function. So let us understand the definition. The function f x comma y is the joint probability distribution or probability mass function of discrete random variables x and y. If the same three conditions, it is extended for two variables now. So there are two random variables x and y. They are already given. Now, what is the first condition? F of x comma y should be greater than or equal to 0. The function, this function is basically what? It is of two variables. Previously it was for only one variable. It is two variables x and y here. That the function should be always greater than or equal to 0. There also it was same. F of x should be greater than or equal to 0. Here, since there are two variables, f of x comma y should be greater than or equal to 0. That is the first condition. Second, there it was sum of all the points in your sample space should be equal to 1. That is probability of all the sample space, all the sample space points should be equal to 1. Here also same thing. So here there are 2 points x and y because two random variables are used. So summation of both should be equal to 1. So don't worry, once you take the example you'll understand clearly like what these symbols mean. Then the third one is the probability distribution, that is PMF function. So here we write it as P of or f of x comma y is equal to P of x equal to x comma y equal to small y. Okay, previously in single variable it was f of x equal to P of x equal to x. But here there are two variables, so we will extend this to two variables. Next. Now, see, since it is there was only one dimension, it is x means only one dimensional. Here x and y means we are dealing with joint, that is two dimension. So when I draw, it is the xy plane, right? One dimensional is only one axis. Two dimensional means x and y plane. So we call it as a plane. Not 2D means a plane. So how will you write what exactly it means? For any region A in the xy plane, probability of x comma y that belongs to that area is equal to sum of all those probabilities. What they mean to say is, this is my x, this is my y. Okay. So let us say there are some points P of x equal to say 1 comma y equal to 1. Then we have P of x equal to 2 comma y equal to, this y equal to 2. This x equal to 2, y equal to 2, y equal to 1. And then say that there is a point here, say P of x equal to 0 comma y equal to 0. So this is xy plane. This is our f of x comma y, the third dimension. We are viewing it in a 3D. What is this area bounded by all this? This is what they are saying. So the area bounded in this xy plane is called as represented by A. So xy that belongs to A. So how will I obtain this? By summing up all these values. So this is how you to visualize. So this is important because when you learn machine learning algorithms, you will be dealing with such kind of imaginations, xy planes, 2-dimensional, 3-dimensional, and all those things. So once you solve the problem, you'll understand in depth. Okay. So let us take an example. A fair coin is tossed 3 times. Let x equal to number of heads, y equal to number of tails. Find the joint PMF of x comma y. So what they are saying, let us write the sample space first. So coin is tossed 3 times. So there will be 3 outcomes. So let us start with head, head, head. Then we have head, head, tail, head, tail, head. Then head, tail, tail. Okay. Then again we will have tail, head, head, tail, head, tail, 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 head, tail, tail, tail. 8 outcomes, right? Now, what is x here? X represents number of heads. Y represents number of tails. Now for this you have to find the joint PMF, probability mass function. The probability mass function is given in a table format. So how to find this? So let us slide this first table first. So there are 2 variables now. There it was only one x and f of x. Here it is x, y, then f of x comma y. So let us say this is the table for f of x comma y. So here we indicate y values. Here in the column we indicate the row values. Okay. Now, so if you observe here, what are the values x can take? X can take 0, it is 0 heads, 1 head, 2 head, 3 heads, right? So 3 heads are possible, 0 to 3. Y can take 0, tail, 1 tail, 2 tail, and 3 tails. Because y represent number of tails. Now, so here you write all x values 0, 1, 2, 3. Here you write 0, 1, all y values 2, 3. Okay. Now, so now you have to find the probability of these cases, possible combinations. What exactly it means when I say f of 0, comma 0? This is nothing but what P of joint probability distribution of x equal to 0, comma y equal to 0. So that means what you have to check, heads are 0, tails are also 0. Is it possible? It's not possible, right? At least one head or one tail is there in the sample space. So this is not possible. So for unknown event, probability of unknown event is already always 0, right? So 0. So instead of finding every combination, first you check which one is not possible. See, when x equal to 0, we'll start from here, x equal to 0. So can y be equal to 1? The total we have to get 3, right? See, when I add x plus y, I should get 3 because the outcome has 3 values. So 0 plus 1 is 1 only. So it is not possible because there is no outcome in the sample space. So minimum 3 should be there. Then 0 and 2. So it will be again 0 only. There is no probability. You cannot calculate the probability. What it means to say is 0, comma 2. That means 0 heads, 2 tails. Is it possible? It's not possible. Now, 0 heads, 3 tails. Is it possible? Yes, it is possible. That means what, all 3 are tails. Now you find that f of 0 comma 3. That means what, p of heads equal to 0, tails equal to 3. What is the probability? So all tails is 1. So 1 by 8. So you put it here, 1 by 8. Next, 1 0 not possible. 1 1 not possible. 1 2 yes possible because it forms 3. So what it says, p of 1 comma 3 is equal to p of x equal to 1 comma y equal to 3. Sorry, 1 comma 2. So 1 head, 2 tails. So 1 head, 2 tails. 1 head, 2 tails. 1 head, 2 tails. 1 head, 2 tails. How many are there? 3 out of 8. 3 by 8. So here write 3 by 8. Then 1 3 not possible. Next 2 0 not possible. 2 1 yes possible. So f of 2 1, that means 2 heads 1 tail. 2 heads 1 tail. Then 2 heads 1 tail. 2 heads 1 tail. So 3 by 8 again. This 3 by 8. 2 2 not possible because it becomes 4. 2 3 not possible. Next 3 0 is possible because f of all 3 heads. All 3 heads is equal to what? So only one what come. So that is 1 by 8. This is 1 by 8. Again 3 1, is it possible? No. 4, it will become 4. 3 2 no. 3 3 no. So now we got the probability mass function. Now how will you find out whether it's correct or not? You have to validate, no? So what is the condition? The sum of the complete area should be 1. That is what they are saying. Second condition. In the single variable it was summation of x, f of x equal to 1. Here summation of x, summation of y, f of x comma y should be equal to 1. What they mean to say? So observe here. First take all the rows sum, 0 plus 0 plus 0 plus 0 plus 0 plus 8, 1 by 8. Then it is 3 by 8, this row. Sum of all the entries here. This is also 3 by 8. Then this is 1 by 8. Add all those, okay. Now similarly for columns, this is 1 by 8, this is 3 by 8, this is also 3 by 8, this is 1 by 8. Now add all this and add all this. So if you add, you should get 1 here. So 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 is 8 by 8, that is 1. Here also 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8 is 1. So it's a valid joint PMF for this question. I hope you understood this. Now second part, B. Find P of x equal to 2, y equal to 1. See, already I got the PMF. So x equal to 2, y is equal to 1. What is that value? 3 by 8. This is equal to 3 by 8. This is how you have to solve. Okay. We'll take one more problem. 2 ballpoint pens are selected at random from a box that contains 3 blue, 2 red, 3 green pens. Let x be the number of blue pens selected. X is number of blue pens. Y is number of red pens. So they are not selecting green in the outcome. Okay. So now What are the total possible outcomes? So total I have to select how many? 2. 2 pens I have to select. So total how many are there? Balls. So 8, right? Out of 8 balls, I have to select 2. So outcomes is what? Total outcome is 8C2. So 8C2 is, I think it is 28. Okay. Now, so you have to find the probability mass function. So again, you draw this table. So this is f of x comma y. This is y. This is x. Okay, this table is f of comma y. PMF, joint PMF. So now we'll write what are the possible values. The total 2 balls are required. What are the possible values for x? So x can be 0, 1, 2, right? I can select 0 blue pens, 1 blue pen or 2 blue pen. Similarly, y. So I can select, because maximum 2, same 0, 1, 2. So right values is 0, 1, 2, 0, 1, 2. Now, so instead of finding all those, first find those which are invalid. You can directly write it as 0. So but be careful here. There are 3 green pens also. So you are choosing from all these 3. So 0, 0, is it possible? Because see, what is that total? I have to get 2 ballpoint pens here. So sum should be 2, either including blue or green or red. Now, both blue and red are 0. Is it possible? Yes, it is possible. Why? I can select 2 from green, no? So this is possible. So let us find that value. So what is that value? F of 0, 0 is equal to. So I am not selecting from blue, I am not selecting from red. So I am selecting 2 pens from green, 3C2, because there are 3 green pens available, divided by 8C2, that is 28. So 3C2 is 3 by 28. Okay. 1 by 28, right? 3 factorial divided by 2 factorial into 1 factorial. So it is 3, sorry. Okay, so we'll write it 3 by 28. Next, 0, 1. Is it possible? Yes, it is possible. So let me write somewhere here. F of 0, 1. F of 0, 1. This is equal to, so 0 blue, 1 red. 1 red means 2C1 into 1 more I should choose from green, 3C1. This will be equal to 6 by 28. This is 6 by 28. Next, 0, 2. So 2 red, 0 blue. This is also possible. Let us write here f of 0, 2. This is equal to, both are red. So 2C, 2 divided by 28. That is 1 divided by 28. This becomes 1 by 28. Next, 1, 0. This is also possible. 1, comma 0. 1 means I have to select 3C1 into 3C1 divided by 28. This is equal to 9 by 28. This is 9 by 28. Then both are 1, 1. So f of 1, comma 1 value into 100 divided by 28. This is again 6 by 28. Now 1 plus 2, this is not possible, right? 0. So it becomes 3. Then 2, 0. Is it possible? Yes. What is that saying? F of 2, comma 0. That is 3C2 into red is 0, 2C0 divided by 28. 3C2 is again 3 by 28. Next, 2 and 1 not possible because it becomes 3, 0. 2 and 2 becomes 4, also 0. So now you check validity of PMF. So add this 3 plus 6, 9, 10 by 28. This is 15 by 28. This is 3 by 28. Here 12 plus 15 by 28. 12 by 28. 1 by 28. So to add them it's 28 by 28. So 1. This is a valid PMF, joint PMF. Next, what is that they are asking? Find the area such that x comma y, x plus y is less than or equal to 1. That means what? What are the possible combination for x plus y less than or equal to 0? So 0, 0, 0, 1, x plus y less than or equal to 1 means, so 0 plus 0, okay, x can be 0, 0, or it can be 0 plus 1, or it can be 1 plus 0. So there is no other combination possible. So for this, you find those functions. So this is nothing but what f of 0, comma 0. This is already you have got. What is that f of 0, comma 0? 3 by 28. That is equal to 3 by 28 plus 0, comma 1, f of 0, comma 1. 0, comma 1 is 6 by 28. Then f of 1, comma 0. 1, comma 0 is 9 by 28. The total area, if you remember that last point explained no, in the definition, this point, this is what you are doing here. For that area, for calculating that area value. So 18 by 28. So this is the answer. I hope you understood this. Next, I will go to the continuous version. So this is simple. Usually discrete cases are a little bit difficult, but joint density continuous functions or random variables, usually you directly integrate, you get the answer. So same thing here. So you write it as f of x comma y greater than or equal to 0 for all x comma y, and then like your single variable minus infinity to infinity and minus infinity to infinity, because I have x and y. So that integral should be equal to 1, area under that plane. For region A in the xy plane, P of xy belongs to A is the integral of that. Previously it was summation, here it is integral. So let us see. This is how it looks like. Okay, there it was a discrete case, so I just joined the points. There are points, but here it's a curve. It is a xy plane. This is x, this is y. This is the function or joint PDF f of x comma y. So just observe here, whatever you are seeing, this no mesh kind of thing in the squares, that is your function f of x comma y. Okay. X and y are the xy plane. Now here the transparent red prism. Okay, this actually shows the area. So what is that I am saying here? On this curve, this whatever here, top, this is the area A on the curve that is given by this plane xy, the variables. Okay, and whatever the blue lines you are seeing, those are the probabilities that you are adding up, blue vertical lines that add up to give the probability volume. So whatever the height you see here, this is the probability volume, or the probability that whatever we are calculating. Area under the curve calculated for single variable. Here it is the volume because it's the xy plane. Okay. These are the single probability values that whatever calculate, no? P1, P2, those values. So this is how you have to imagine. Okay. Next, we'll see an example, simple. So a privately owned bus operates both a drive-in and walk-in facility. Let X and Y denote appropriate portions of time that drive-in and walk-in facilities are in use. Suppose the joint density function is given like this. Okay, f of x comma y equal to 2 by 5, 2x plus 3y, and the intervals are given. Now you have to find out, verify condition 2 of the definition, that is verify whether it is a joint PDF or not, probability density function, and then you find the value of this area under this values 1 by 0 to 1 by 2 and 1 by 4 to 1 by 2. Let us see how to test this. So f of x comma y is equal to 2 by 5, 2x plus 3y, and they are in the range, both are in the range 0 to 1. Okay, so now how will you verify the PDF? So the PDF is given by what? For the integral in that area, f of xy should be equal to 1. So now, what are the upper bound and lower bounds they are given? So let us write the function first. 2 by 5, 2x plus 3y dx dy, because two variable joint. Now first is x. Okay, I will write the x interval 0 to 1, then 0 to 1. This is how I have to integrate now. First let us integrate with respect to x. So let us take this 2 by 5 outside. So 0 to 1, 2x plus 3y. So keeping y as constant, okay, integrate the x. So it becomes 2x square by 2 plus 3xy in the, what is the range, 0 to 1, then dy. So this is equal to 2 by 5, 0 to 1. To put the values, so it becomes 2 cancel, so x square 1 plus 3y, and then if you put 0 it will be 0 only. So now you integrate with respect to y. So 2 by 5, so integration of 1 plus 3y, that is y plus 3y square divided by 2 from 0 to 1 in the interval 0 to 1. This will be equal to 2 by 5 into 1 plus 3 by 2. So this will be equal to 2 by 5 into 5 by 2. So 1. So this is valid joint PDF. Okay. Next. What is that? The second point, second thing they're asking. So integrate, find the area in this interval. X is between 0 to 1 by 2 and y is between 1 by 4 to 1 by 2. So integral in the area 0 to 1 by 2, 1 by 4 to 1 by 2. Right. So your function is 2 by 5 2x plus 3y dx dy. So you now go on integrating. This is a, this is b. Okay. So 2 by 5. First, let us integrate with x. So x square plus 3xy in the interval 0 to 1 by 2 dy. So this comes out to be 2 by 5, 1 by 4, 1 by 2. So 1 by 2 whole square is 1 by 4 plus 3 by 2y. The rest becomes 0. So dy. Now you integrate with respect to y. This becomes y by 4 plus 3y square. Okay, 2 to cancel. In the range 1 by 4 to 1 by 2. So if you evaluate this, we will get it as 13 by 160. Next, one more example we take. So they are given f of x comma y equal to 6xy. So they are asking you to validate. Is it a valid PMF? Integral of both are again 0, 1, 0, 1 interval. 6 will write outside xy dx dy. So this is equal to 0 to 1 x square y squared by 2y, then 0 to 1. This comes out to be 6, 0 to 1. So put the value here. So it will be y by 2 dy. So dy is missing. Now integrate with y. So it will become y square by 4 in the interval 1 comma 0. This is 6 into 1 by 4. So 3 by 2. This is equal to 1.5. So this is not equal to 1. Therefore, it's not valid joint PDF probability density function joint. Not valid. So in B they are asking if instead of 6 it is C. What is the C value so that it becomes a valid joint PDF? Okay. So same thing. Let us integrate using this 0, 1 x dx dy. So this will remain same. Instead of 6 I will put C here. X square y by y. Okay. 1 0 dy equal to C 0 1 y by 2 dy is equal to C into y square by 4 1 0 is equal to 6 C into 1 by 4 should be equal to 1. No? Valid PDF means it should be valid joint. PDF means the sum should be area should be 1. So that implies C is equal to 4. If C is equal to 4, then this will become valid PDF. Thank you for watching. Please like, subscribe and share. From the next video, we will continue with the two more important concepts, that is marginal distributions and conditional probability distribution.